This video will introduce you to a standard multiple regression. We'll go through what a standard multiple regression is, when it's appropriate to use, and the assumptions associated with the test. Before we go into what a multiple regression is, let's just quickly remind you what a linear regression is. Remember that linear regression determines a model to predict the value of one variable from another. So a linear regression basically describes the equation of a straight line. A multiple regression is very similar to a linear regression, and it's a natural extension of this model. But instead of predicting values of an outcome from just one predictor, a multiple regression is used to predict values of an outcome from several predictors. It describes the hypothetical model of the relationship between several variables. So, like with a linear regression, a multiple regression also has an equation. The outcome variable is expressed as a linear combination of the predictor variables. So depending on how many predictor variables there are, will depend on how many x variables there are in your equation. So let's break this down and go through what it all means. Y refers to the predicted value of y, or your outcome variable. A, just like your linear regression, refers to the y-intercept. So when all x variables are 0, this is the value of the outcome variable. x1 is the score on predictor variable 1, and x2 represents the score on the predictor variable 2. B, like in a linear regression, refers to the slope or gradient of the line. This value tells you how much the y variable changes when variable x increases by 1 unit. Each variable will have its own coefficient of b. So in summary, your outcome variable, or y, is predicted from a combination of all the variables multiplied by their respective coefficients, which in this case is represented by b. Now, just be aware that multiple regressions are typically performed on correlational data, and as you all know, correlation does not imply causation. So a regression uses an equation model which allows us to predict an outcome variable. It doesn't imply that they're causing changes to the outcome variable. So predicting also does not mean causation. Here are some research examples where it may be appropriate to use a multiple regression. You may notice that with each of the research questions, they're using more than one predictor variable to predict an outcome variable. So let's take a closer look at, let's say, example 2. A researcher investigated whether levels of job satisfaction can be predicted from annual income, average number of hours worked per week, and number of employees in the organization. So you can see that levels of job satisfaction is our outcome variable, and we have 3 predictor variables in this question. Take a look at example 1 and 3 and see whether you can identify the outcome variable and the number of predictor variables in each of the examples. So a multiple regression has many assumptions that need to be met in order for the results to be valid. Only the first one is methodological, which is interval or ratio data, and assumes that your outcome variable should be on an interval or ratio scale of measurement. Now, the rest of the assumptions here can be tested through SPSS. So let's take a look at these assumptions in more detail. Independence of errors. This is where a multiple regression assumes that for any 2 observations, the errors or residual terms should be independent or uncorrelated with one another. This means that the observations should be independent and there shouldn't be any systematic relationship visible amongst the residuals. A multiple regression is pretty sensitive to outliers and other influential cases. So an outlier is considered to be a case which differs substantially from the main trend of data, and checking for these extreme scores should be part of the initial data screening process. Next thing we're going to look at is multicollinearity, or in this case, no multicollinearity. A multiple regression assumes that predictors should not have a perfect linear relationship. So that means that there should be no multicollinearity in the data set and they should not correlate too highly. Normality for a multiple regression assumes that the residuals, so residuals are the differences between the observed and predictor values, these values should be roughly normally distributed. Our last two assumptions also refer to the residuals and assume that 1, the relationship is linear, and 2, that the variance in the residuals is homogeneous across the full range of predictor values. So that relates to homoscedasticity. That now concludes the introductory video to a multiple regression.